principle was 2 decades ago due to efforts of and attempts of Geoffrey Hinton and David Rumelhart and Ronald Williams in 1986 due to publishing a paper about learning presentation by back propagation errors that says us back propagation is a procedure to repeatedly adjust the weights so as to minimize the difference between actual output and design output. So you have both of them, something that is design and something that is the real. Like, for example, you want to do a regression about some points about the function, and you have your expectation about the data for your real expectation, but approximate function tells you something again based on error that they are a bit different. Okay, so hidden layers, which are the neuron nodes stacked in between inputs and outputs, allowing neural networks to learn more complicated features such as XOR, XNOR, and and all of the things that you can see in logic, or about something that you learn about logic electronics. Okay, all of these operators and operands are here. Operators are these, and operands are your input data. Okay, then neural networks with hidden layers are literally just adding more neurons in between input and output layers. So data in the input layer is labeled by X with subscripts 1 to the M. That we say X1, X indice 1, X indice 2, or X indice M. So neurons in the hidden layer are labeled by H with subscript. Note for a hidden layer, it's M and not M, since the number of hidden layer neurons might be different from the number of them in input data. And you see in the graph below, the hidden layer neurons are also labeled with a subscript 1. So using labels is not very good, because it's based on the human work, and we are trying to present some of the algorithms that it eliminates and omits all human action, and you will do all the things based on the algorithm and digitalization. Okay, this is so that when you have several hidden layers, you can identify which hidden layer it is. First hidden layer has superscript 1, second layer has superscript 2, and so on. And like in graph 3 that you can see, output is labeled as Y hat, as I told you later, okay, before. So you will see here the single layer perceptron right here, perceptron with hidden layer, input layer, and you will see the output, and even you will see here input layer, and you will have the output hidden layer and output. So the left is single layer perceptron. This is without hidden layer, but right is perceptron with hidden layer. That the violet tones here, violet circles no here, shows you the hidden layer. Okay, so we label input layer as X with subscripts 1, 2 till M, and hidden layer by H, again by with a hat, that is Y hat. Okay, so again we have about multi-layer perceptron. To make life easier, we will use some jargons to clear things out a bit. I know jargons can be annoying, but you will get used to them. First, if we have M input data, X1, X2, Xm, we call it M features. We call this M features. A feature is just one variable we consider as having an influence to a specific outcome. Okay, like our example on the outcome of if you decide to learn DL or not. We have 3 features. 1, will you earn more money after learning DL? Or 2, is the math programming hard? Or 3, do you need a GPU to start with? So there are some questions that are proposed about your outcome and what you will attain, what is attainable or is gained for you. Okay. So about multi-layer perceptron, you have secondly we have multiply each of m features with weight w1, w2, w index m, and sum of them altogether. This is the dot product, scalar product, as you see w dot x based on this formulation, and sigma I from 1 to m based on this summation w index I in xi. Okay. Then about this, we have all information again here about this that we have said before. You know all of them about. So about multi-layer perceptron, we have an example about cat or dog. So you will see as input we have a cat or dog. So you have an input layer, hidden layer, and output. So you it's a kind of recognition that at last you will get the dog or you will get a cat. So the answer has been here a dog. Okay. So all of them are pattern recognition algorithms, and everything that you will see in many applications of the trade market, about social media, that we will see here. Okay. So we have here the model representation. The model representation is computing system inspired by biological network that constitute animal and human brain. Such systems learn to perform tasks by considering examples generally without being performed with any task-specific rules. Okay. The neural network again constructed from three of layers: input, hidden, and output layers. Okay, as you know them. So about is the model representation. So the you will see each node is connected with each node from the next layer, and each connection, black arrow, has particular weight. Weight can be seen as impact that the node has on the node from the next layer. So if we take a look on one node, it would be like this, okay? And you have some these information too. These circles represent activation nodes and usually are noted as W or weight or theta. Weight and theta are both about activation or weight function, okay? And the red circle is output or is predicted values, or values in the case of multiple output classes or types, okay? So you will see here the model representation: inputs, weights, weighted sums, and you have unit step function here based on 1 and 0, and you have the output. Okay, again we have some information about them, and you need to know about this. All the nodes from the previous layer, yellow, are connected with it. All these connections represent the weights impact when all the nodes values from the yellow layer are multiplied with their weights, and all this is summarized. It gives some value for the top blue node. The blue node has predefined as activation function or unit step function, which defines if this node will be activated or how active it will be based on the summarized value. So the additional node with value 1, that is called bias node. Bias node is initial node that you consider about initial approximation, about the function, about everything that you have as supposition at first, that you will make it at first, okay? Based on your contract, based on your supposition. So in order to understand the mathematical equation, we will use a simpler neural network model. This model will have 4 input nodes or 3 plus 1 bias. Okay, 3 input layers and 1 bias. 1 hidden layer with 4 nodes, 3 plus 1 bias, and 1 output node. Okay, so you will see here x1, x2, x3, and 1 plus 1 as a one of the layers that we have considered as a bias, okay, a predefined layer. So here is plus 1, okay. Here is layer 2 based on the hidden layer. Here is layer 3 based on the second hidden layer, and you have here the WBX as a function that you have defined based on the previous things that you have considered. And then we are going to mark bias nodes as X0 and A0 respectively. So the input nodes can be placed in one vector X and the nodes from the hidden layer in vector A. You will see here X is equal to a vector X0, X1, X2, X3, and A is equal to A0, A02, A12, A22, and A32. And you know the X is 4 in one size and A is 4 in one size, okay? And the weights arrows are usually noted as theta or W. In this case, we will note them as theta. The weights between the input and the hidden layer represent 3.4 matrix. It's the size of the matrix, 3 in 4 matrix. And the weights between the hidden layer and the output layer will represent 1 and 4 matrix. That, as you know about the rules of matrix product, okay? If the network has a units in layer J and B units in layer J plus 1, then theta will be one of dimension B multiplied by A plus 1. It's based on the linear algebra principle. So you need to know a bit about linear algebra and its application, especially about applied linear algebra. That is very important for you, because the pure format of linear algebra is very hard for beginners of artificial intelligence or machine learning, but you need to know some of the main principles and concepts of linear algebra to know more about machine learning, okay? So your matrix is here, the theta 1 is here. Next, we want to compute the activation nodes from the hidden layer. In order to do that, we need to multiply the input vector X and the weights matrix theta 1 for the first layer, X multiplied by theta 1, and then apply the activation function G. What we get is this. You can see this. Compute activation nodes based on the A is equal to G theta transpose in X. Is the closed matrix form that we have defined, and you will see here the open format of this closed format that you will see here, okay? Again, by multiplying the hidden layer vector with weights matrix theta for the second layer, multiplied by theta, we get output for the hypothesis function or its supposition function. That is very important. Compute output node value based on the hypothesis. H is equal to Hx, H is equal to G theta transpose in A, and this is the full format that has been opened here that you will see here. Again, this example is only with one hidden layer and with 4 nodes there. If we try to generalize for neural networks with multiple hidden layers and multiple nodes in each of the layers, we would get the next formula. It is the generalized compute node value function. Based on this, you will see here the full the generalized format based on the Y is equal to Wx transpose plus P, where we have L layers with N nodes and L minus 1 layer with M nodes that we have predefined earlier, okay? So activation function in neural network, the activation functions defines if given nodes should be activated or not based on the weighted sum, okay? Let's define this weighted sum value as Z. In this section, we would explain why a step function and linear function won't work. That is very important. I said you why we need to use the sigmoid function and nonlinear function, and what are the advantages and disadvantages, and you will see here. And talk about the sigmoid function, one of the most popular activation function. So there are many of activation functions like tangent, hyperbolic, like activation function based on radial basing function that you need to know from approximation theory in applied mathematics or pure and applied mathematics. There are also other functions which I leave aside for no, so we will see later. Okay. The activation function about this step function, if z is bigger than threshold, activate the node by value 1, and if z is smaller than threshold, don't activate the node by and consider the value 0. Okay, this looks nice, but it has a drawbacks. It has a disadvantages, since the node can only have value 1 or 0 as output. Okay, in case when we would want to map multiple output classes nodes, we got a problem. The problem is that it is possible multiple output classes or nodes to be activated to have the value 1. So we are not able to properly classify or decide about this item. So I will tell you why it will happen. Okay. First, about the linear function. If we have y is equal to ax, okay, it's the linear function. However, using the linear function is a neural network would cause the output layer to be linear function. So we are not able to map any linear, nonlinear data, because you need to have to do curve fitting based on your nonlinear data. So the linear data cannot very good for your fitting or your regression. Okay, the proof for this is given for this. F(x) is equal to this, and you have f(x) and gx here. Okay, f(x) is equal to this, and gx, two linear function. F(x) is x plus 3, and gx is 2x 2 multiplied by x plus 5. Okay, and you have here the function composition. We get g of x is equal to gfx. gfx is equal to 2x plus 3 plus 5 is 2x plus 11. Okay, which is also a linear function. So this it makes a problem about making an approximation, making a guess based on hypothesis that you have considered first, and then you want to have nonlinear fitting, and it's not completely possible. It's not possible. Okay, and a sigmoid function, as you have here, based on 1 divided by 1 plus exponential minus x, and it is why it is used for neural networks. You will see here, it is one of the most widely used activation functions today. Its equation is given with the formula below. It can be defined as tangent hyperbolic function by different results, or by any different cases like radial basis function that affects on output results too. So good reasons to use sigmoid function. What is it? So it was very important question that my PhD supervisor asked me. That is very important to know about it. Okay, so let's see what happens. Okay, okay, let me see what happens. These are very important, the reasons. One, it has multiple properties which make it so popular. It's nonlinear function. The range values are between 0 and 1. That makes very easier computations. And between -2 and 2 on x-axis, the function is very steep. So it has some steep that cause function to tend to classify values either 0 or 1. That are very important things that you can consider about the sigmoid function. So if you change the value of between this interval, this open interval, you will see you don't get good values. It's because of the asymptotic behavior of the sigmoid function that you need to see. It's more details in applied and pure mathematics. Okay. So because of these properties, it allows the node to take any values between 0 and 1. In the end, in the case of multiple output classes, classes, this would result with different probabilities of activation for each output class, and we will choose the one with the highest activation probability value. So what is it here? This is sigmoid function, and you will see the behavioral function and what is it, you can find from calculus many of features of this function that is very applicable and is very interesting for mathematicians. Okay, so you will see many kinds of sigmoid function based on three colors, red, blue, and green. You will see here the different parts, and you can define based on your different neural networks that you want to define. Okay. And the bias node, using the bias node is usually critical for creating successful learning model. In short, a bias value allows to shift the activation function to the left or right, and it helps getting better fit for data. So you can see again about the fitting data based on the nonlinear data as your input, okay, as your input data. Better prediction function as output. So based on your nonlinear fit data in output, you will get better prediction function as output, as you expected, okay, as you anticipated. So below there are three sigmoid functions that we draw, where you can notice how multiplication, add or subtract the value x by some value can influence the function. Multiplying x makes the function steeper, and add and subtract x makes shift the function left or right. And you can see this in the calculus again, based on the behavior of functions in mathematics and calculus. Calculus 1, calculus 2, calculus 3, and everything that you have learned from preliminary calculus or at university. So the cost function is very important. Let's start with defining the general equation for cost function. This function presents the sum of the error difference between the predicted value and the real value or labeled value. Let's come back to work. Okay, so we were talking about the cost function. This function represents the sum of the error difference between the predicted value and the real labeled value. The general cost function, you have this j theta is equal to this function. Since this is the type of classification problem, y can only take the discrete values 0 and 1. It can only be in one type of class. For example, if we classify images of dogs, for example, based on the class 1, and cats based on the class 2, and bears based on the class 3. We are doing now a kind of human action as labeling. Okay, if the input image is dog, for example, if the input image is dog, the output classes will be value 1 for dog class and value 0 for the other classes. Okay, so just for example about the animal that you need to the result is just dog. Okay, and if you get other result, you need to turn back the value 0. Okay, this means that we want our hypothesis to satisfy this. The hypothesis function ranges is between 0 and 1, h theta x. Okay, between 0 and 1. Okay, and so that's why we will define our hypothesis as h theta x is equal to g theta transpose in x. Okay, where g is in this case will be the sigmoid function, since this function has the range values between 0 and 1, because based on the mathematics, okay, based on the mathematics, the range of this function, not the domain, will be between 0 and 1 interval, open interval of 0 and 1. So our goal is to optimize the cost function. So we need to find minimum j theta. Okay, but the sigmoid function is non-convex function. What is non-function? Non-convex function is when you have 2 points between a circle that you want to make a connection between two lines. If the line can pass from your shape, so it's the non-convex function, and you will see here what I say about that. And which means that there are multiple local minimums. So you will see about the Hessian matrix. If you consider the J theta, it's about the minimization or optimization problem, and you will find based on local minimums or local points that has the that get the minimum values based on your computation. So it's not guaranteed to converge or to find to the global minimum. What we need is convex function in order that the gradient descent algorithm, that is very important to be able to find the global minimum or minimize J theta. So minimize J theta is computed based on gradient descent algorithm. So you have gradient value based on the Hessian matrix and many of them. To be able to find the global minimum and minimize J theta, in order to do that, we use the log function, okay? So you will see here, we have convex function. If you consider 2 points here and you make a connection between 2 points, it will consider in this set, in this subset. But about this, if you consider, if you draw a line between this point and this point, this will be out of this area that defined for this line or this area. So this is the area that you will see in operational research in many parts of it. And what is very important is convex and functional convex functional programming. That is very important, and you need to know about some concepts about the affine space and affine continuity and many of the things about what is convex and non-convex function from the mathematics in numerical analysis, computational mathematics, or much more. Okay, so this is the main idea that you need to know. So the cost function, so that's why we use the following cost function for the neural network. The cost of h theta x and y. So the function cost is based on h theta x and y is equal to, if y is 1, consider minus log h theta x. If y is 0, consider minus log 1 minus h theta x. Okay, in this case, where label value y is equal to 1, the hypothesis is minus log hx, or for elsewhere or almost everywhere parts, as you see from the numerical from real analysis, almost everywhere parts of that you can consider about this criteria function, log 1 minus hx. Okay, so you have these criteria about something that you have considered. Okay, so we will go further. The cost function, so you will see here the cost function here. This institution is pretty simple. If you look at the function graphs, let's first look at the case when y is equal to 1, then minus log hx would like the graph below, something like this. Okay, like it has asymptotic behavior as you see here, and we are only interested in the interval of 0 and 1 x-axis interval, since hypothesis can only take values in that range. Means even for your hypothesis, range of values that you have defined for your input data will be between the open interval of 0 and 1. Okay, it is very important that you need to know. Okay, so you will see here, and what we can see from the graph is that f y is equal to 1 and hx approaches value of 1 from each x-axis, the cost approaches the value 0, hx minus y, that would be 0, since it's the right prediction. Okay, otherwise if hx approaches 0, the cost function goes to infinity. Why is infinity? Because you have a function by asymptotic behavior, and when it tends to some points, you will see it will go to infinity. That is very important. Okay, for very large cost. For more information, please visit these links that I will share with you, all of them, after this presentation. Back propagation algorithm, what we need to do is to minimize the cost function j theta using the optimal set of values for theta or weight or w values. Back propagation is a method we use in order to compute the partial derivatives of j theta. The partial derivative, as you know from calculus 1, calculus 2, calculus 3, from pure and applied mathematics, is then using gradient descent algorithm or to find Hessian matrix. That is very important, even for operational research, and even about the network and programming languages, linear and nonlinear programming, that you need again some problems like minimization and maximization, or it's called optimization. So this partial derivative value is then used in gradient descent algorithm for calculating the theta values for the neural network that minimize the cost function j theta. The general form of the gradient descent will be here. So you need to consider this. Repeat this: theta j is equal to the j minus alpha round theta j to compute j theta. Okay, it's recursive. Okay, back propagation algorithm is an algorithm for supervised learning of artificial neural networks using gradient descent. We will tell you what is supervised learning. Given an artificial neural network and an error function, the method calculates the gradient of the error function with respect to the neural network's weights. It is a generalization of the delta rule for perceptrons to multi-layer feed-forward neural networks. So what is this? Here we will see here that we want to talk about this. So the back propagation algorithm is the calculation of gradient that proceeds backwards through the network with the gradient of the final layer of weights being calculated first and gradient of the first layer of weights being calculated last. So it's like LIFO, last in, first out in computer science. Okay, it's about, you will see again, calculation of the gradient proceeds backwards through the network with the gradient of the final layer of weights being calculated first and the gradient of first layer of the weights being calculated last. So they have been substituted. Okay, the partial computations of the gradient from one layer are reused in the computation of the gradient for the previous layer. This backwards flow of the error information allows for efficient computation of the gradient at each layer versus naive approach of calculating the gradient of each layer separately. So if you want to consider each layer computation separately, it is not efficient method. So you need to use this approach. Okay, so back propagation's probability has experienced the recent resurgence given the widespread adoption of the deep neural network. You will see all of them here. I will tell you what happens here. Let me come to full page that you will see here better about what I want to say. Okay, and it's about it's good, I think. No, I think it's good. Yes. No is good. The voice is good. Okay. I hope you are good. You have a nice time. I hope you are not tired. And I will continue. Okay, are you ready to continue? Okay. I hope you enjoy about my presentation, and you have any question, I will be here to help you. Okay, all of you. Okay. Okay. So you will see here this. Let me see. I have your presentation here too. Do you have my presentation here, or I need to represent again? No. Sharing is good. Okay. Sharing is good. The voice is. Thank you. Oh. Okay. Good. Well. So as we define, the back propagation algorithm is calculating the derivative of cost function with respect to each theta weight parameter. By doing this, we determine how sensitive is the cost function j theta to each of these theta weight parameters. It also helps us determine how much we should change each theta weight parameter when computing the gradient descent. Okay, so at the end we get the model that best fits our data. It's about the nonlinear fitting, because we have considered the nonlinear function or nonlinear input data. So that's why sigmoid function, that's why sum of nonlinear function is good for our neural network that we are trying to design. Okay, this is very important to know. Okay, this is the reason of why derivatives are here, and we are here to talk about forward propagation calculation. This process is actually getting the neural network output value based on the given input. This algorithm is used to calculate the cost value. What it does is the same mathematical process as one described in section 2, model representation mathematics, where is the end. In the end, we get our hypothesis value. You will see here. Again, we had this that we had computed this earlier based on the compact matrix form that you consider G W transpose X that we added. Okay, do you remember this about this? Okay, so okay, we have after we got the HX value hypothesis, we use the cost function equation to calculate the cost for given set of inputs. These are all the set of inputs. X is equal to A1, Z J plus 1 is equal to theta J RJ. They are like this recursive format. RJ plus 1 is equal to sigma Z J plus 1, and H theta X is equal to RL is equal to sigma Z upper index L. Okay, so here we can notice how forward propagation works and how a neural network generates the predictions. Okay, so we will go more the forward propagation calculation, the generalized cost function. We have the proof since y or label data is always equal to 0 or 1. We can write the cost function in one equation. The cost function based on two variables, input and output, independent variable or dependent variable. Cost h theta x and y is equal to minus y log h theta x minus 1 minus y log this. Okay, and if we fully write our cost function with the summation, we would get the cost function in the case of one output node. This is j theta is equal to this function that you see here. Okay, that is the generalized format for about forward propagation calculation. Okay, let me see more. Again, you will see here the generalized cost function for multi-class classification. This is only for the case where there is only one node in the output layer for neural networks. If we generalize this for multiple output nodes, multi-class, we get this function, generalized cost function in this form. The right parts of the equation in this represent the cost function regularization. This regularization prevent the data from overfitting by reducing the magnitude or values of theta. So you will have a control parameter for each part of a neural network that you can set it or adjust it, okay? So you need to know all of them are dependent together. Just about the function that you have the independent variable as the input data that are optional, but optionality of the input data depends on something that you consider, because data can be clustering data, video, sound, text, string, everything. So you need to consider which kind of data you consider and what is expected to be resulted in your output, okay? So we have this, and that delta rule for perceptrons to multi-layer feed-forward neural networks. We have the delta rule is a gradient descent linear algorithm for updating the weights of the inputs to artificial neurons in single-layer neural network. It is a special case of the more general backpropagation algorithm for a neuron J with activation function Gx. The delta rule for J's or J's or weight Wji is given by this delta W index Ji is equal to alpha T index J minus Y index J G prime or differentiation of G with respect to Hj and multiplied by X index I. Okay, this is the delta rule that is considered, and it will be in fact the rate function that you have from the physics from delta X with delta T to delta T that you want to consider the moment velocity. So this is the rate. This is the rate that you have in mathematics. Okay. So we will go more the delta rule for perceptrons here, where alpha is a small constant called learning rate. Alpha is learning rate. Gx is the neuron's activation function. G prime is derivative of G. T index J is target output. Hj is weighted sum of the neuron's input. Yj is actual output, and xi is the ith input. And if that holds, it holds that Hj is equal to sigma sigma for summation of x index I multiplied by W index Ji, and Yj is equal to Gij. Okay. So you will see again the delta rule here, as we will see here what is it. Let me go further more. We have more. Okay, we are some from here. It will be more sweeter. We want to consider general concept of neural networks. So artificial intelligence, that is very important. OI is the ability of the digital computer or computer control robot to perform tasks commonly associated with intelligent beings. The term is frequently applied to the project of developing system endowed with the intellectual processes characteristic of the human, such as the ability to reason, discover meaning, generalize, or learn from past experience. So you can make a prediction, you can make a task, you can make, for example, a predefined behavior, a predefined pattern based on your past experience by artificial intelligence, and then you can make it, you can use it in a digital computer, you can make it systematic or digitalized. Okay, this is very important to know. Okay, you can use it for many things. For example, about the mathematical theorems, it can be very important. The complex task, I can do many complex tasks like discovering proofs or mathematical theorems, or playing chess with great proficiency, and many other things about robots, everything. Okay. So what is artificial intelligence definition? Artificial intelligence can be loosely interpreted to mean incorporating human intelligence to machine. Okay, and still, despite continuing advances in computer processing speed and memory capacity, there are as yet no programs that can match human flexibility over the wider domains or in tasks requiring much everyday knowledge. On the other hand, so yes, this is very important. Maybe till the year 2030, we will have many complex systems that can compete with the human brain activities. Okay, so on the other hand, some programs have attained the performance levels of human experts and professionals in performing certain specific tasks, so that artificial intelligence or AI in this limited sense is found in applications as diverse as medical diagnosis. These are applications that are very important: medical diagnosis, computer search engines, and voice or handwriting recognition or pattern recognition, that are very important applications of AI. Okay, so we have more note. Whenever a machine completes tasks based on the set of stipulated rules that solve the problems or algorithms, such as intelligent behavior, is what called artificial intelligence. For example, some such machines can move and manipulate objects, recognize whether someone has raised the hands, or solve other problems. AI-powered machines are usually classified into two groups that are very important: general and narrow. The general artificial intelligence AI machines can intelligently solve the problems like the ones mentioned above. The narrow intelligence AI machines can perform a specific tasks very well, sometimes better than humans, though they are limited in scope. So the technology used for classifying image on Pinterest social media as an example of narrow AI as a social media analysis. So there is a kind of classification of data based on the Twitter, based on the Pinterest, based on the Reddit, based on Facebook, and many things that you can use it. And you will see many different aspects of machine learning, artificial intelligence, and deep learning in this presentation. Okay, you will see here an example. Here is the table that identifies the type of fruit based on its characteristics. You will see the weights of the fruits here, the texture, rough or smooth, and the type of fruit, orange, apple, and there is no for example, here is unknown for the last one. Okay. As you can see on the table above, the fruits are differentiated based on their weight and texture. However, the last row gives only weight and texture without the type of the fruit. So what is the riddle behind it? And a machine learning algorithm can be developed to try to try to identify whether the fruit is an orange or an apple. This is something that we had about a cat or dog. Okay. After the algorithm is fed with training data, so first you need to training data. What is for training data? When you are, for example, God forbid, when you are the disabled, you need to work out a lot of exercise in order to motivate your hands, your disabled organs or your body. This card is an example of training data. You are trying to activate your neurons of your brains. Okay, so training data is in artificial intelligence works with this situation, with this interpretation by in a lower level for this information that we have here. After the algorithm is fed with the training data, it will learn the different characteristics between an orange and apple. So it will tell you it is orange or apple. Therefore, if provided the data of weight and texture, it can predict accurately the type of fruit with those characteristics. Okay. What is machine learning definition? Machine learning definition after artificial intelligence use statistics to find patterns in massive amounts of data. Okay, what is it and what we are trying to tell it? Okay, what is very important? Okay, let me push Control and D. Okay. Document properties here, excuse me. Control and D. Okay. Can you hear me? It's good? Okay. So what is machine learning definition? Let me check again some of the information that you have here. Let me check together. There is no problem here. Uh, do you have all my voice, dears? Do you have all my words? Anyone is audible to tell me that it is good? Okay.
Yes, sir, it's good. It's good.
Okay. Okay. Okay.
You are loud and clear there.
Okay. I will try to continue and finish it soon.
Please
Finish it soon.
proceed, sir.
It's not a lot. Okay. Okay. What is machine learning definition? Machine learning, like artificial intelligence or AI, is like ML in abbreviation. Use statistics or statistical methods or probability to find patterns in massive amounts of data. So when you talk about probability, please keep it in mind that we talk about prediction. So many parts, many phenomena in the world needs prediction, like what happens the earthquake. For example, earthquake no, but the earthquake center knew what happens and predicted, okay, at that time the earthquake happens. So this is the prediction is very good information for you, but especially if you want to know about the Bitcoin prices, about the exchange prices, about the Nasdaq share, about everything that you want to know as a predictor sooner than other people in order to have a great decide for your life, everything that changed your life. So prediction is very important, and machine learning has came to many parts of the world. Even machine learning has changed many aspects of physics, especially some parts of the physics that is about the particle physics, that all the phenomena happen in deterministic states. So when we use into probability, everything is different. So we have lots of accidents, lots of patterns, lots of states about quantum computing, about everything in the world that you need to predict based on lots of information. For example, about the coronavirus, about HIV/AIDS, everything. You need lots of behaviors from the coronavirus, lots of behaviors from HIV/AIDS. So all of the things, all of the information can be predicted and can be analyzed based on the machine learning, because the human brain cannot do this information because of huge data that has been considered. Okay, so this is very important to know. Okay, so machine learning algorithm use statistics to find the patterns in massive amounts of data, and the data here encompasses a lot of things: numbers, words, images, clicks, and what you have. Okay, if it can be digitally stored, it can be fed into a machine learning algorithm. Machine learning is a process that powers many of the services that we can use today, recommendation systems like those on Netflix, YouTube, Spotify, Kodi, and many of the things that you use in United States or many other countries in the world that uses many kind of social media or SoundCloud, everything. Search engines like Google or Baidu from China, social media feeds like Facebook and Twitter, voice assistants like Siri or Alexa, all of them use this. The list goes on. It means that there are lots of the applications about this. Okay, so in all of these instances, each platform is collecting as much as data about you. Okay, voice is good now. Okay, voice is good.
It's,
Okay,
it's
okay.
good.
Okay, voice is good. Voice is disconnected again. Okay, let me come back. Let me come back. Excuse me. Voice is good. Let me write for all. Voice is good. Okay, let me come back to the presentation. Okay. We were here okay, in all of these instances, each platform is collecting as much as data about you as possible, what genres you like watching, what links you are clicking, what statues you are reacting to, and using machine learning to make a highly educated guess about what you might want next, or in the case of a voice assistant, about which words match the best, the funny sounds coming out of your mouth. So, do you know what we are doing? Everything in Facebook that you like, everything that you watch on YouTube, everything that you subscribe, everything that you say about your virtual voice assistant in many companies, all of this information have a kind of, for example, prediction of your behavior. So based on this prediction, they consider to suggest you some of the things. So this is the kind of prediction. So Facebook and YouTube can introduce you many pages to like based on your something that you like or post on the internet, on Facebook and Twitter. So you will find many favorite things, many favorite items that they suggest you because they have processed your data. Okay, so this is very important application of machine learning. The main process, frankly, this process is quite basic. Find the pattern, apply the pattern, but it pretty much runs the world. That's in the big part thanks to an invitation in 1986, courtesy of Geoffrey Hinton, today known as a father of deep learning, or DL, and also Alan Turing effects. Late Alan Turing was killed, but he was very great scientist that is one of the fathers of computational intelligence. Okay, that you know him. So you need to know about the history about that later. Okay, note, as the name suggests, machine learning can be loosely interpreted to mean powering computer systems with the ability to learn. The invention of ML, machine learning, is to enable machines to learn by themselves using the provided data and make accurate predictions. Okay? ML is a subset of artificial intelligence, or AI. In fact, it's simply a technique for realizing AI. It is a method of training algorithms such that they can learn how to make decisions. And training a machine learning entails giving a lot of data to the algorithm and allowing it to learn more about the processed information. Okay, these are very important things that you learned about the machine learning. Okay, what is supervised learning that I talked to you about that? One last thing you need to know is machine learning or deep learning comes in three flavors: supervised, unsupervised, and reinforcement. In supervised learning, the most prevalent item is the data is labeled to tell the machine exactly what patterns it should look for. That we talked about that. Okay, about the patterns. Think of it as something like a sniffer dog that will hunt down targets once it knows the scene is after. That's what you are doing when you press play on a Netflix show. You are telling the algorithm to find similar shows. So everything that you consider on the internet, everything that you do about your social behavior and interaction with animals, with people, all of them can be simulated as you see here. Okay, so I will go further. So based on the human data information and based on the computer programs, computer artificial intelligence, and based on the digitalization, based on the machine learning and artificial intelligence. Okay, as I told you. So here, human experts acts as a teacher where we feed the computer with the training data containing the input or predictors, and we show it the correct answers or output, and from the data, the computer should be able to learn the patterns. Supervised learning algorithms try to model relationships and dependencies between the target prediction output and the output features such that we can predict the output values for new data based on those relationships which is learned from the previous data sets. So you can in fact, you have some previous data sets, that you have some data about that, you have a prediction about them, and you learn machine based on the supervised learning to act based on this information that you have about predict the output values. So you have, for example, you have some data on Twitter, and someone wants to know what is your personality based on something that you have clicked on the internet about it. So they are trying to analyze the data that you have, for example, retweeted on the internet or liked it, and try to guess your personality or your behavior. This is something very important about supervised learning. Okay, so we will go more. Application of supervised learning will be in predictive model. We have labeled data, and as you told you, the labeled data is based on the human work, but it's not good variation because digitalization of identified data is very better than doing a human work. Okay, because it makes lots of time, and maybe it makes lots of space to process the data, and it ameliorates the complexity of your algorithm about your machine learning or your artificial intelligence that you want to design. Okay, and the main types of the supervised learning problems include regression and classification problems. Okay, and we will go more about regression and classification problems. What are them? Classification problems ask the algorithm to predict the discrete value, identifying the input data as a member of particular class or group in a training data set of animal images. That would mean each photo was pre-labeled as a cat, as I told you, as a cat, koala, or turtle. What was it? What is it? What of this as a guess in output? This is very important. So this is the algorithm is then evaluated by how accuracy it can correctly classify new images of other koalas or turtles. So on the other hand, regression problems look at the continuous data. So we have both continuous and discrete data. In the calculus, as you know, we have continuous, we have discrete data that you can do sigma or product on them. Okay, so one use case about is a linear regression should sound familiar from the algebra class. Given a particular x value, what's the expected value for the y variable? Oh, yes. Well, so what is the expected value of y based on the function f? So do we have the function f here? So we need to know more about these questions about these problems in artificial intelligence and machine learning. So a more lots of variables like an algorithm that predicts the price of an apartment in San Francisco, for example, based on the square footage, location, and proximity to public transport. Or, for example, we have some of the applications about, for example, about the Google Map, about many things that you consider about some of the applications that you need for global positioning, everything that you consider about your car to find your route, your path, and your escort or your highway you need, and which distance is better. All of them are defined based on these applications, or about choosing your home. What is for example, the closeness to the airport, to transport service, everything. So you need to know about them. That is very important. Okay. Or Verizon X, that you have used one of them. That is very important in the United States, or other companies that you know. Some maybe I have forgotten the name about the company that you know them, and you can write for me here about the name of company for path navigation. I have forgotten it now. But it's just a name, and recently Iranian CEO is managed this company in United States. Okay, let me tell you. Okay, about the cat, koala, or turtle, the classification algorithm can tell the difference. So based on the data that you have considered, you don't know your data will be cat or koala or turtle. So based on this classification or training your data, you will have your result about this. For example, the output is a koala or turtle or a cat. Okay. This is classification algorithm. Okay. Let me more applications of supervised learning. List of common algorithms. The nearest neighbors or Conyers algorithm in analyzing scattered data in statistics. Naive-Bayes classification algorithm based on Bayes theorems in probability courses, that you will see some of the resources that you can see or study for further study later. Decision trees in graph algorithms, linear regression in statistics, support vector machines or SVM to analyze the data for classification and regression to train the data that you can see here, and neural networks. These are all applications of supervised learning. Okay, application of supervised learning, again about these are the labeled data consisting of a set of training examples where each example is a pair consists of an input and these are output value, also called a supervisory signal, labels, and etc. Classification is the goal to predict discrete values, e.g. one or for example 1 or 0, true or false, spam or not spam. Excuse me, the name of the application was Uber for path navigation. Excuse me, I didn't forget at that. It was Uber. Like Google Map, that all of them have AI and ML based algorithms to show result to you. And the regression is the goal is to predict continuous values like home prices and everything that you can find based on the regression algorithms. Okay, you can see all of them for further study based on the links and other information that I will send you later. Okay. And what is unsupervised learning? Unsupervised learning data has no labels, so it is very better for us because labels have many problems for us. For time consuming and human action. Okay, machines just looks for whatever patterns it can find. This is like letting a dog smell tons of different objects and sorting them into groups with similar smells. Okay, maybe you have a dog, you have lots of, for example, people, and he tries to smell them in order to find smuggling drugs, or to find a smuggler that he or she is carrying drugs or opium or everything. Okay, these are a pattern, a biological pattern that it can be used for machine learning and artificial intelligence too. So these are unsupervised learning. So I will tell you as an example. Okay, unsupervised techniques are not popular because they have less obvious application. Interestingly, they have gained traction in cybersecurity. So you will use it in cybersecurity for many of data, loads of data that you need to categorize all of them, and you will to find hoaxes. You find Ponzi scammers. You find hackers, and this categorized data and without no label based on the pattern cognition. Okay. So the computer is trained with unlabeled data. Here's no teacher at all. So actually the computer might be able to teach you new things after it learns patterns in data. So the computer learns some patterns like some programming languages that you start to write a preset data or initial data. Then the algorithm in unsupervised learning try to analyze it in order to get new data in output based on the previous data or initial data that you didn't know what to look for in the data, but you can find it. Especially it has application in data mining because of loss of data in factories, loss of data in many big companies, and you don't know how to use them in further applications and further development of their companies. Okay, this is very important of important application of unsupervised learning. So I will go further. There are family of machine learning algorithms which are mainly used in pattern detection and descriptive modeling. Here, there are no output categories or labels here based on which algorithm can try to model relationships. These algorithms try to use techniques on the input data to mine for rules, detect patterns, and summarize the group of data points which help in driving meaningful insight and describe the data better to the users. So unsupervised learning tries to use a kind of digital process in order to calculating data, in order to analyze data, aggregation of data, everything that you can consider about it. Okay, is a kind of digitalization, not labeling. Okay, so application of unsupervised learning is about descriptive model. The main types of unsupervised learning include clustering algorithms and association rules learning algorithms. These are some of the algorithms that you can see. Clustered algorithms are about clustered data, scattered data, and clustering. The algorithms, like for example, about the wireless sensor networks, that each node or each sensor in each modem in wireless sensor networks or in Wi-Fi can be considered as a cluster node, and you can try to make an optimized node of network for better enhancement of wireless sensor networks or your Wi-Fi networks. Okay, and common clustering association rules. Okay, all of them that are in computer science and artificial intelligence, machine learning in order to do a statistical process. Okay, what's the difference between supervised, unsupervised, and semi-supervised reinforcement learning? In a supervised learning model, the algorithm learns on a labeled data set that you told you is a human action, providing an answer key the algorithm can use to evaluate its accuracy on training data. And unsupervised model, in contrast, provides unlabeled data that algorithm tries to make sense by extracting features and patterns on its own. Okay, semi-supervised learning takes a middle ground. It uses a small amount of labeled data, bolstering a larger set of unlabeled data. So we have both of them in semi-supervised: labeled data and unlabeled data. Okay. And reinforcement learning trains an algorithm with a reward system, providing feedback when an artificial intelligence agent performs the best action in a particular situation. For example, when you work with the money and he tries to do something for you, for example, he gives you a box and you will give to the monkey or gorilla a banana, okay? So it's a kind of reward. So here reward can be a return of something, or return back. Maybe your computer return back something as a result to your output, and you will find from the return back of something that some process has happened on your digital processing of your programming code. Okay, so you need to know this. And with supervised machine learning, the algorithm learns from the labeled data. You will see here the input data, the labeled observation, training set, test set, machine learner, prediction model, and here there are the statistical process, and then you have output. Okay, and about unsupervised learning, models automatically extract features and find patterns in the data. So you will have data from, for example, breast cancers, from bacteria, from everything, from tomography, from pathology, from, for example, about sonography, about the pattern recognition, about voice recognition, face recognition. All of them, unsupervised learning can be used in many applications of social media, and even, for example, you will find it about this, the third application in airport, in customs, when you want to leave a country to another, and at the airport a guardman tries to save the picture from you in order to find a pattern that you are a healthy person or a smuggler, or you have drug, or you have some bad backgrounds from your country, you are a theft, you are a crime, everything. Everything can be extracted and can be obtained from unsupervised learning model without any label. Okay, so what is reinforcement learning? Lastly, we have reinforcement learning, the last frontier of machine learning, that learns by trial and error to achieve a clear objective. It tries out lots of different things and is rewarded or penalized depending on whether its behavior help or hinder it from reaching its objective. This is like giving and withholding treats when teaching a dog a new trick. Yes, if you something learn to a dog, you will see him a bone. Okay, it is for you. It's a food for you. Okay. Reinforcement learning is the basis of Google's AlphaGo program that famously beat the best human players in the complex game of Go, or about chess players. So you will have a reward about this kind of learning. So we will see more about what is it and what is in details. But I am trying to finish it as soon as possible. So method aimed at using observations gathered from the interaction with the environment to take actions that would maximize the reward or minimize the risk. So reinforcement learning algorithm called the agent continuously learns from the environment in the iterative fashion. In the process, the agent learns from its experience of the environment until it explores the full range of possible states. So when you learn something to a dog, when you learn something to a system, after that, by reinforcement learning, you can get a full range of new behaviors that can system by reinforcement learning, system by AI and ML by reinforcement learning can do it or learns it and do it for you. For example, put me this cell phone, okay, this robot will give you. Or for example, answer me this phone call, so robot do it for you. So it is some of the duties that can learn to do, okay, in an iterative fashion. It's a routine that happens, okay. So it's also reinforcement learning is a type of machine learning, and they were also a branch of artificial intelligence. It also machines and software agents to automatically determine the ideal behavior within the specific context in order to maximize its performance. Simply reward feedback is required for the agent to learn its behavior. This is known as a reinforcement signal. So this signal tells you, okay, you have get a reward about about something that you have learned to your system before, and this is the result that you have get from a signal or a feedback that you have get from a signal that is work properly. Okay, that works properly. Okay, and this is do you have my voice? It is going to finish as soon as possible. This is reinforcement learning. Please tell me if you don't have my voice. All audiences that have my voice, is this topic is enjoyable to all of you? Is enjoyable to all? Let me write.
Yes, sir, you are audible properly.
Okay. Let me continue to finish it very soon. This is reinforcement learning based on the state, agent, reward, environment, and action that happens. Okay, so we will go further. There are many different algorithms that tackle this issue. As a matter of fact, reinforcement learning is defined by a specific type of the problem, and all its solutions are classed as reinforcement learning algorithms. In the problem, an agent is supposed decide the best action to select based on his current state. When this step is repeated, the problem is known as a Markov chain or decision process. Markov chain or Markov decision process. Markov is a Russian mathematician that tries to formulate or make a big course of stochastic processes. And Markov chain has many applications in the world in order to predict many probabilities, and you will use it many things about it. And so probability about reinforcement learning works well. Okay, so in order to produce intelligent programs, also called agents, reinforcement learning goes through the following steps. So we will see here. Input state is observed by the agent. Decision-making function is used to make the agent perform an action. After the action is performed, the agent receives the reward or reinforcement from the environment. Then the state action pair information about the reward is stored. That is for example, the final result that is stored, that you know what happened about your system. Okay, about the electronic system, everything that can be digitalized or intelligent. Okay, so more list of what is reinforcement learning. What are the applications? It's about the Q learning. You need to know about, you need to search about them. Temporal difference or TD or deep adversarial networks, and we talk about this at the end of this webinar. That is very important that you need to know. What is use cases? Some application of reinforcement learning algorithm are the computer played board games, just like chess, Go, robotic hands, and self-driving cars. Self-driving cars like BMW or Mercedes-Benz, that all the cars are have been driven autonomous and without any human interfere, and also they are all have 5G or 5G communication together by sending waves and try to convey or conduct the pathways without any accidents together. Okay, so these are very important. What is semi-supervised learning? There are no labels for all the observation in the data, so labels are present for all the observation, and this learning falls in the between these two. In many practical solutions, the cost to the label is quite high, since it requires a skilled human expert to do that, as I told you. So in the absence of labels in the majority of the observations, but in present few, semi-supervised algorithms are the best candidates for the model building. These methods exploit the idea that even though the group memberships of the unlabeled data are known, so this data carries important information about the group parameters. So what happens? So you have lots of, for example, information about this, and you will see. I can share with you lots of information about semi-supervised and what happens about the hidden layer about this data, and you have unknown data in the input, but you have a prediction and result about this unlabeled data. Then this data carries important information about the group parameter that.
Dear participants, I have already shared the feedback link with you in the chat box. You can fill it up. But the session is not over right till now. But if you want to fill it right now, you can do so. Am I audible to you?
Audio is very low, sir.
Yes.
Come back again to
Professor
you.
Ahmed.
Let me finish about the all parts of this. We have this. I will tell you, and we will finish it very soon. Okay, and then attendance can ask the questions. So,
Sir, feedback link, sir.
we talked about the supervised. Okay, it is really finished soon. Just please give me a time to finish it. Okay. What is deep learning? Deep learning is a machine learning algorithm that uses a technique which gives machines an enhanced ability to find and amplify even the smallest pattern. This technique is called the deep neural network, or DNNs. We say DNNs deep because it has many layers of simple computational nodes that work together to merge through the data and deliver a final result in the form of a prediction. Okay, so we will see there the difference.
Dr. Hamid.
Okay.
Dr. Hamid, sorry to interrupt you. Dr. Hamid, sorry to interrupt you. This is SS Ghosh, coordinator of this webinar. Please share your screen, sir. Please share. Yeah. Thank you.
A screen. Okay. Let me.
Please present your screen, sir. Yeah.
Okay. Screen. Okay. Let me screen with you. Excuse me for my problems. Maybe my internet problems here is a lot due to filtering the internet. Please accept my apology.
It's okay. It's okay, sir.
Okay. I hope this information will be useful.
Since the start of this.
Okay. So let me tell about this deep learning. I was telling about the deep learning. What is deep learning? Deep learning is an algorithm that uses the technique, or DP, a technique that which gives the machines an enhanced ability to find and amplify even the smallest patterns. This technique is called a deep neural network. Deep because it has many layers of simple computational nodes that work together to merge through data and deliver a final result in the form of the prediction. Okay, so we have this difference between machine learning and deep learning. You will see machine learning here and deep learning. About the machine learning, you have input, feature extraction, and I will tell you what is it. Feature extraction, classification that you know, and the output, for example, car or not car. And about the deep learning, we have feature extraction plus classification. They are together done in a process of deep learning. Input, feature extraction plus classification, and output again, car or not car. So what are the difference? So You need to know about this item to learn about the feature extraction, about the curse of dimensionality. What is it? In machine learning, dimensionality simply refers to the number of features, i.e. input variables in your dataset, okay? When the number of features is very large relative to the number of observations, therefore, certain algorithms struggles or try to train effective models. So this is called the curse of dimensionality, and it's especially relevant about scatters problems like wireless sensor networks, Wi-Fi, that you need to rely on distance calculations. So distance calculations is completely comes back to wireless sensor network models, that the distances of the modems, networks, and origin center of the ISP, that is very important, should place or should location, which location it should be, and where is your home in order to make connection with the ISP or with the internet base center. Okay, so let's state the curse of the dimensionality by an example as an excellent analogy. See this by me. Let's say you have a straight line by 100 yards, any somewhere on it, the line, and it takes 2 minutes. So let's say you have a square 100 yards, 100 yards on each side, and you drop a penny somewhere on it. It would be pretty hard, like searching across 2 football fields stuck together. It could take days. So now a cube 100 yards across, that's like searching a 30-story building the size of a football stadium. Ouch, it's a lot. So little by little, the problem is getting harder and harder, okay? So the difficulty of searching through the space gets a lot harder as you have more dimensions. So we are trying to do reduction of dimensions. That is very important in many parts of the mathematics, artificial intelligence, machine learning, and about in linear algebra, that we have reduction and also normalization or orthogonalization or we were here. Feature. I am trying to finishing very soon. Very soon it's finished. Okay. Feature selection is for filtering irrelevant or redundant features from your dataset. The key difference between feature selection and extraction is that feature selection keeps a subset of original features, while feature extraction creates brand new ones. To be clear, some supervised algorithms already have built-in feature selection, such as regularized regression and random forest, and you know about random forest from graph theory. Okay. Typically, we recommend starting with these algorithms if they fit your task. So as a standalone task, feature selection can be unsupervised, like variance thresholds, or supervised like generic algorithms. So most of the time for wireless sensor networks analysis, you need to use Cummings algorithm and generic algorithms together. So generic algorithms is very important, and it's some of the most important parts of some of the processes in processes for machine learning that you need to know. One of the most important algorithms that you can use for many based on the biological concept, but you can use for many mathematical or many processes that you can solve the problems by this algorithm. You can have a further study for that. You can also combine multiple methods if needed. Okay. Again, feature extraction is for creating a smaller set of features that still captures most of the useful information. Again, feature selection keeps a subset of original features, while feature extraction creates new ones. As with feature selection, some algorithms already have built-in feature extraction. The best example is deep learning, which extracts increasingly useful representation of raw input data through each hidden neutral layer. So you have raw input data in input. So in hidden neural layer, they will do some. So they will programize some of the algorithms that you know, like generic algorithms, like some of other things that you can study further about getting the meaningful data for output. Okay, based on the simplicity that you talked about the deep learning algorithms. Okay, as you saw for first. Okay. And this is not, there are many possible techniques for classification of data. That means principal component analysis, PCA, and linear discriminant analysis, LDA, are two commonly used techniques for data classification and dimensionality reduction. Linear discriminant analysis easily handles the case where the within class frequency are unequal and their performance has been examined on randomly generated test data. Okay, your data test. This method maximizes the ratio of between class variance to the within class variance in any particular data set, thereby guaranteeing maximal separability. So these are all most important techniques that we have. Note, the use of linear discriminant analysis for data classification is applied to classification problem in speech recognition. We decided to implement an algorithm for LDA in hopes of providing better classification compared to principal component analysis. The prime difference between LDA and PCA is that PCA does more of feature classification and LDA does data classification. So it's very important to know. Feature classification for PCA and LDA do more data classification. So in PCA, the shape and location of objects when transformed the location, but only tries to provide more class separability and draw a decision region between the given classes. So you have a partition or you have a line between two parts of the data. At the end of this conference, I have sent Abu Kamal Mustafa, professor of UCLA, Stanford University, about this classification of data that are separated part of data that are about, you will see about everything. For example, about head, tails, coin, some of the coins that you put up and you send it up and then you will get head or tail. So these are two discrete set of data about the results for tail and results for head. So these are separated from together. So the letter of separability is about this, the partition about data. And LDA doesn't change the location, but only try to provide more class separability and draw a decision region between the given classes, as you told you. And it is for better understand distribution of feature data. And you will see here, as you see here, as I told you, this is a partition between these classified data here, showing the data set and test vector in original. So set 1 this and set 2 this, and this is the partition between two. These are independent, not dependent together. Okay, these are independent. Okay, feature extraction. As a standalone task, feature extraction can be unsupervised like PCA or supervised like LDA. PCA is principal component analysis. That's again is an unsupervised algorithm that creates linear combinations of original features. The new features are orthogonal, which means that they are uncorrelated. Yes, they are not correlated or coercive. Okay. Furthermore, they are ranked in order of the explained variance about statistical analysis. Okay. The first principal component PC1 explains the mass variance in your data set, and PC2 explains the second most second most variance, and so on. Okay, based on your analysis and numerical simulation that you do about your data points. Okay, data sets. And feature extraction, again, this is a for example about the statistical analysis, and you can do based on the Minitab, based on R, based on Python, based on for example SPSS, and every Excel, and every software that you can do data mining, okay, and analytics. Therefore, you can reduce dimensionality by limiting the number of principal components to keep based on cumulative explained variance. For example, you might decide to keep only as many principal components as needed to reach a cumulative explained variance of 90%. Cumulative accumulation or accumulation error is one of them. Different bit. Cumulative something is about the variance is the statistics. So please make a difference between two concepts in statistics and in numerical or computational mathematics. Cumulative error is another thing, and cumulative variance is another thing different. So you need to refer to probability courses and statistics to learn more about them, and to try to learn it in code writing, okay? Code programming. You should always normalize your data set before performing PCA because the transformer is dependent on scale. If you don't do that, the features are on the largest scale would not dominate your new principal components. So it means that you cannot do your action, you cannot do any algorithm because of the large set of data that you have, and so the process is very heavy and very complicated. Okay, again, we have some strengths and weaknesses. It's versatile technique that works with well in practice. It's simple and fast. You can easily test and offer several variation and extensions like kernel PCA, sparse PCA to tackle specific roadblocks. And weaknesses is new principal components are not interpretable, which may be deal breaker in some setting. In addition, you must still manually set or tune a threshold for cumulative explained variance. About something that you told you about in the statistics is cumulative variance. So these are some parameters that you need to do manually, not digitally, and it shows the weaknesses of your method. Okay, about feature extraction. And the linear discriminant analysis is it also creates linear combination of your original features. Unlike PCA, the LDA doesn't maximize explained variance, and it's maximize separability between the classes. As I told you, between the partition between two independent data sets. Okay, therefore LDA is a supervised method that can only be used with labeled data. So which is better, LDA or PCA? Well, results will vary from the problem to problem. Okay, so I will go about the LDA. Improve the predictive performance of extracted features. Also offers variations like quadratic LDA to tackle specific roadblocks. But weaknesses is new features are not easily interruptible again, and you must still manually set or tune the number of components to keep. Okay, so it's a weaknesses. So note autoencoders are neural networks that are trained to reconstruct their original inputs. For example, image autoencoders are trained to reproduce their original image instead of classifying the image as a dog or as a cat. So how is this helpful? Well, the key is to structure the hidden layer to have fewer neurons that input or output rather than the input or output layers. Thus, that hidden layer will learn to produce smaller representation of original image. Okay? Because you use the input image as a target input, autoencoders are considered unsupervised. They can be used directly, like for example, for image compression or stacking in sequence in deep learning about input, hidden layer, and output. You have decode of data from encode of data from input, and again you have decode of data. Is you have encode and decode of data, okay, or they can be combined together, okay. So encoders, autoencoders are considered unsupervised. They can be used directly, like image compression, or in sequence, like in deep learning. And the strands, they perform well for certain types of data, such as data and audio data, and weaknesses, they have problems. They require more data to train. They are not used as general purpose dimensional reduction algorithms. So this part is not holds for them. That is weaknesses of this part of autoencoders. Okay, this class of autoencoders as networks. Okay. So what is deep learning? As mentioned, DL algorithms are roughly inspired by the information processing pattern found in the human brain, just like we use our brain to identify patterns or classify various types of information. Deep learning algorithms can be taught to accomplish the same task for machines the same as our brain. The brain usually tries to decipher the information it receives. It achieves this through labeling and assigning the items into various categories. So we have some this is very important. For example, artificial neural networks, ANNs, are a type of algorithms that aim to imitate the way our brains make decisions. Comparing deep learning vs machine learning can assist you to understand their suitable difference. For example, when DL can automatically discover the features to be used for classification, ML requires these features to be provided manually. Furthermore, in contrast to ML, DL needs high-end machines and considerably big amounts of training data to deliver accurate results. So again, a data set, we have talked about the labels of data set that is human task, and it's very time taking. For example, about the X-ray, about sentiment analysis of tweeters, or about the video, everything. So we have talked about this. We will put it aside, and I will go further. And difference between machine learning, artificial intelligence, and deep learning. As you see, deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. And here is an image that attempts to visualize this distinction between them. Here, you will see here, it is the point. Artificial intelligence includes machine learning, and machine learning includes deep learning. Okay, and differences between them. So AI is the all-encompassing concept that initially erupted, then followed by ML that did thrive later, then less with DL, is a promising to escalate the advance of AI to another level. Okay, and I need to finish this. This picture says us AI means getting a computer to mimic human behavior in some way. Machine learning is a subset of AI, and it consists of techniques that enable computers to figure things out from the data and deliver AI applications. And deep learning, meanwhile, is a subset of machine learning that enables computers to solve more complex problems, like quantum computers, like everything. That there are some tools for solving complicated and complex problems. Okay. And what are convolutional neural networks? Convolutional neural networks like this, you will see here. For example, about guessing the number is 2, but in output it must be guessed. It is 0, 1, 2, 9, and this is the structures that you will define, and we have to finish it very soon. Convolutional neural networks is a deep learning algorithm which can take in an input image assign importance, learning weights and biases to various aspects of objects in image, and to be able to differentiate one from the other. The pre-processing required in convolutional networks is much lower as compared to other classifications classification algorithm. While in primitive methods, filters, it's very important to use every characteristics. So you make filters to do everything. For example, you make filters to get a channel on your satellite network. You make filters to get, for example, about a website. So filters is very important to get just optional something that you want from a network, from a system, from everything. Okay, so this is filtered or based on characteristics. The architecture of convolutional neural networks is analogous to that of the connectivity of pattern of neurons in the human brain, and was inspired by the organization of visual cortex in the brain. Individual neurons respond to stimuli only in restricted region of the visual field known as the receptive field. A collection of such field overlap to cover the entire visual areas. Okay, so we will go further very soon. You will see here, and there are 7 applications for convolutional neural network: decoding facial recognition, analyzing documents, historic and environmental collections, understanding climate and forecast. Gray areas means better image resolution about what human being sees. Something that you see in eye is different with something that machine learning or convolutional neural network or CNNs can diagnose, or that can say us what is it. Okay, or about advertising or online marketing in Facebook, YouTube, everything, or about the mathematical biology, or about brain cancer detection, or many issues in healthcare that is very important. About, for example, about breast cancer, sonography, everything. So one neural network and multi-layer perception is a class of feed-forward artificial neural network. Multi-layer perceptrons are sometimes colloquially referred to as vanilla neural network, especially when they have a single hidden layer. In summary, in a vanilla neural network, a fixed-size input vector is transformed into a fixed-size output vector. So we have both of them, fixed-size input and fixed-size output vector. Such a network becomes recurrent when you repeatedly apply the transformation to a series of given input and produce a series of output vectors based on input and outputs based on a performation. Okay, there is no preset limitation to the size of the vector, and in addition to generating the output, which is a function of input and hidden state, we update the hidden state itself based on the input and use hidden state itself based on the input and use it in processing the next input. Okay, so you will see here this network, the Wallinger neural network. You will see x11, x12, x13. These ways are connected to hidden layers, and then hidden layers again are connected to y or y hat as output layer that you will see here. And we have input size 3 and 1 hidden layer, and 1 output at is size 1. You use size 3, size 2 for hidden layer, and 1 for output layer. Okay, and recurring neural networks add an interesting twist to basic neural networks. A vanilla neural network takes in fixed size vectors as input, which limits its usage in situations that involve a series type input with no predetermined size. RNNs or recurrent neural networks are designed to take a series of input with no predetermined limit on size. A single input item from the series is related to others and likely has an influence on its neighbors. Neighbors means from the nodes or other nodes that are you will see in neural networks as a full network that you will see here. A recurrent neural network with a hidden state that is meant to carry pertinent information from one input item in the series to others. So recurrent neural networks, also known as RNNs, are a class of neural networks that allow previous outputs to be used as inputs while having hidden state. So you will see here, it means that it has a heritage here about the previous node with respect to the next node, okay? Rather than the next node. So you will see here, recurrent neural networks are a type of neural network where the output from previous step are fed as input to current step. In the traditional neural networks, all the inputs and outputs are independent from each other, but in the cases like when it is required to predict the next word of the sentence, like for example about Microsoft Word, that you write, for example, I am on the, for example, he writes, for example, way, or for example, nice to, it says nice to meet you. The previous words are required, and hence there is a need to remember the previous words. Thus, RNN came to existence. We solved this issue with the help of a hidden layer. The main and most important feature of RNN is a hidden state, which remembers some information about a sequence of data that you consider. Okay. Then RNN have a memory which remembers all information about what has been calculated. It uses same parameters for each input as it performs the same task on the all inputs or hidden layers to produce the output. This reduces the complexity of parameters, unlike other neural networks. So we have here the reduction of complexity of parameters, unlike other neural networks. It's very important. Okay, so the data here is normalized, and we don't have that curse. Okay, and you will see here how RNN works. The working of RNN can be understood with the help of the below example. Suppose there is a deeper network with an one input layer, 3 hidden layers, and 1 input layer, 1 output layer. Then, like other neural networks, each hidden layer will have its own set of weights and biases. Let's say for hidden layer 1, the weights and the biases are W1 and B1, weight 1 and bias 1, and W2 and base 2, bias 2 for the second hidden layer, and weight 3 and bias 3 for third hidden layer. This means that each of these layers are independent of each other. It means that, i.e., they do not memorize the previous outputs, so they cannot have any information about the previous outputs. Okay, so you will see here how it works. RNN converts the independent activations into dependent activations by providing the same weights and biases to all the layers. Thus, therefore, they reduce the complexity of increasing parameters and memorizing each previous outputs by giving each output as input to the next hidden layer. So output will be substituted as an input value, and then it go to the next layer. Okay, next layer. Hence, these 3 layers can be joined together such that the weights and biases of all the hidden layers is the same into a single recurrent layer. Okay, so here you will see how RNN works. RNN support processing of sequential data by addition of the loop. You will see a loop here, hidden layer. This is the loop. We say rolled, but here this is unrolled. You will see here unrolled because you don't see any feedback or loop on hidden layer. Okay, so other RNN supports processing of sequential data by addition of a loop. This loop allows the network to stop through sequential input data whilst persisting the state of nodes in the hidden layer between the steps, a sort of working memory. The following image gives a conceptual presentation of how this works. RNN can be viewed as many copies of a feed-forward ANN executing in a chain. You will see it's like a chain, but it's not like this. Okay, you will see the difference here. Okay, so recursive neural networks is really similar to this, but by a difference. A recursive network is just a generalization of recurrent network. In a recurrent network, the weights are shared and dimensionality remains constant along the length of sequence, because how would you deal with position-dependent ways when you encounter a sequence at test time of different lengths to any you saw at train time. In a recursive network, the weights are shared and the dimensionality remains constant at every node for the same reason, okay? So you will see here the recursive neural networks. You will see x2, y2, x1, y1, x3, y3, x4, y4, x6, y6. So all the input and output are related together here, okay? X2 has a relation with the output of x1, or for example, x6 has an output with has a relation with output of x5. So it means the recursive neural network as defined. So recursive vs recurrent, it means recursive neural network or recursive artificial networks with a certain structure that of linear chain, whereas recursive neural networks operate on any hierarchical structure combining child representation into parent representation, because the child and parent means they have some information, that heritage, that they keep it and then they use it for different locations, different nodes that they are using, okay? So recurrent neural networks operate on the linear progression of time, combining the previous time step and the hidden presentation into the presentation for the current time step. And recurrent neural networks are in fact recursive neural networks. Also, both are usually denoted by the same acronym R and N, okay? But in short, recurrent neural networks are recurring over the time, and it means, or i.e., recursive network is just a generalization of recurrent neural network, okay? So for more information about recursive neural networks, you can see this full mathematical recurrent neural network about recursive neural networks review. This is very good place for formula about it that you need to see for further study. And about the generative adversarial network definition that it was presented in 2016 seminar is really new hot topic of neural networks that you need to know. Generative adversarial networks, or GANs, or algorithmic architecture that use two neural networks, putting one against the other, times the adversarial, in order to generate new synthetic instances of data that can pass for real data. They are used widely in image generation, video generation, and voice generation. So let's see one of the applications. What are the application of this about the voice, video, and image? But about the previous network, just we had image and voice, but we didn't have about the video generation and video processing. So it was very important use of GANs, or generative adversarial network. GANs were introduced in a paper by Jan Goodfellow and other researchers at University of Montreal, Canada, including Yoshua Bengio in 2014, referring to GANs. Facebook's AI research director Jan LeCun called adversarial training the most interesting idea in the last 10 years in ML. You can see paper, the archive paper here. And generative adversarial networks, or GANs for short, are an approach to generative modeling using deep learning methods such as convolutional neural networks. Generative modeling is an unsupervised learning task in machine learning that involves automatically discovering and learning the regularities or patterns in input data in such a way that the model can be used to generate or output new examples that plausibly could have been drawn from the original data set, okay? And GANs are a clever way of training a generative model by framing the problem as a supervised learning problem with two submodels. Please see these submodels that are adversarial. the generator model that we train to generate new examples, and the discriminator model that tries to classify examples as either real from the domain or fake generated. This information is real or fake. This Twitter information is real or fake. Okay, so this is very important. And general adversarial neural networks, you can see the block diagram here. This is random input, real images, generator, samples, two samples. Here is discriminator, and you will see discriminator loss here and generator loss here. And what are the difference between them? The discriminator and generator in GANs. A generative adversarial network GAN has two parts. The generator learns to generate plausible data. The generated instances become negative training examples for discriminator. The discriminator, so for the second, the discriminator learns to distinguish the generator's fake data from the real data. The discriminator penalizes the generator for producing implausible results. So they are these parts of discriminator and generator are like a guard together, are trying to complete together, or are trying to supervise together. If some part has trying to do wrong things, the other part do a penalty against it in order to correct it. Okay, correct it. It's very important about this. So we are at the finishing of this part. Discriminator and generator in GANs. When the training begins, the generator produces obviously fake data, and the discriminator quickly learns to tell that is fake. For example, the generated data is this. So you have real data. It's a real data, real USD dollar, 10 USD dollar. Okay. Here is the good link of Google developers that you need to know about the GANs. And discriminator and generator, again, he is this at the end. The training progress, the generator gets closer to producing output that can fully distribute. You can make a trick for them. It's say, okay, it's fake and it's real. And finally, if generator training goes well, the discriminator gets worse at telling the differences between real and fake. It starts to classify fake data as real, and its accuracy decreases. It says, okay, it's fake, and both of them are real. So this accuracy is around to 100% at the final level. Okay, final step. And good references for your further study is new era of AI at QLattice. So try to sign up to abzu.ai and learning from data lectures full on YouTube from Professor Abu Kamal Abu Yasser Mustafa from California Technology, Caltech University. These are very good YouTube videos for you to know about them, about everything that we covered, but in a full video course. Okay. And about machine learning magistery is very good because it sends you lots of information in email about machine learning step by step, and you can learn lots of things about that. And simulation tools and software about AI, ML, and DP are BECA workbench for machine learning that is very famous now. And this organization, Machine Learning Mastery, recently has introduced it, but it's very old tools for simulation of AI, but it's very good. For a long time, I was searching for many good tools for machine learning, but lastly I found that it is here for you for more study. VECA, open source for you, neurons.ai, Scikit software that is very important, and about 6 other open source data mining tools, and also about MATLAB deep learning. MATLAB is one of the good software for neural networks and simulation. Also R, Python, TensorFlow, PyTorch for Python. This is the end. Thank you so much for your attention about the webinar and all the information we will share with you. for further information. And if you have any questions, I am ready to answer. Thank you so much. Okay, dear professors, if
sir,
you have any questions,
I would
am
like
ready.
to request you to keep the slide or link that was given afterwards, those link for learning the course and also the software. You can give it to us.
Thank you so much. Thank you so much. Okay, all of the things about this presentation was completely practical, and I tried to send all information that you need about each neural network that you need to know. All the basic principles to start to study experience from artificial intelligence and my social activities on LinkedIn and many other social media on the internet about propagating and sharing knowledge about the I, ML, and DP for other people and how to use them in their lives. So there have been many questions for me in this time, but I tried to fill the gap for in telecommunication, in Raspberry Pi, in Internet of Things, in laser communication, all the parts in physics, in everything that you want to learn, you need to use I. I is used for many applications. For example, about fusion centers, American scientists tried a phenomena in physics by AI process. That is very hard process in physics if they wanted to spend lots of money about other engineering processes. But AI is a good phenomena to do all these applications very good. So I is trying to come into quantum machine learning that is further beyond than the study about this course for this speech, because I need to teach you the quantum physics, the basics of quantum physics, and the main idea of physics that I learned based on main founder of physics, Professor Dr. Hossein Javadi, that is main founder of creative particle of Higgs theory. That I am very thankful to him to become familiar with this concepts, and I tried to share with you all information about the AI based on the application in physics and engineering with you about the all new trends, you know. However, there are many informations that you need to know, but I didn't have time to share with you, but I can be in touch with Professor Sudipta Das about this information that you need to know about sharing books, about sharing links, about sharing codes. So I will help you about all of the things, and we can make a good Telegram or WhatsApp teams about sharing all information in order to make new advanced and new more professional seminars and conferences in the field of AI, ML, or DP, not just sufficient to not just to be sufficient to basic information. But it was not really basic, because I tried to send you all of the information about something that happened during many years about the machine learning. So it was very enjoyable for me that I will share to you. It was my honor to talk to you today. So I am ready, all ears, to know about your questions. You send me questions in the text type, or you read me the question. Everything that you do, I am do my best for you at any time. Okay, I'm here to do my best. Thank you. Okay, please tell me about your question. Dear Professor Das, if they have any questions, please tell me to know. I am very happy to know about the question. Uh, one of my questions is the subjects was very heavy and very hard for people, or you have tried to learn something or enjoy something? That is very important for me based on the question that you
Yes,
will feel
yes.
about me, because it's very important. And at last of any semester of class that I have with my students in free and university courses, I will try to talk to my students about them, what you have learned and what is your expectation about me and what I can do for that. Okay, let me check the comments and testimonials about what you have written for me here.
Okay, Dr. Hamid,
Okay,
actually,
please.
yeah, actually,
Okay,
it's a
please.
very, can you hear me?
Okay, please ask me many questions and let me copy your questions here. Your questions, and let me
Yes,
copy
yes,
the links that you
yes.
have sent.
There is
And
one question. Actually, someone JB Joy, he is asking, sir, please explain cost function again.
once time again.
Cost function again. He needs explanation of cost function.
Pulse function.
Yes.
Okay. Pulse function is another type of function in mathematics. We have block functions, block pulse function, but these are readily come to the formulation of neural networks based on the initial definition. So it depends on what location you want to define it. For example, when I talk to you about the sigmoid function as a linear function, I told you it can be substituted with the tangent hyperbolic or radial basis function. So about the activation functions, that makes the control between the as a hidden layer between the input and output. So you need to use pulse functions for that too. But please pay attention to which application want to use and which results give you. It's very important. It's very important. Just paying attention to what is type function, this type of function is not very important, is not the case of issue, but is not the main case. But the pulse function, maybe you have some different about different definition about them, but in this case maybe you need to consider about the activation. But I have a question about the attendant that have asked me the question, what application that wants to use about it. So it is very important. If he asks me this question, he must be responsible about this question too. What is the reason for using pulse function? So pulse function have a definition in mathematics. Okay, it's true. So what is the reason for using it? So I am a reviewer and ask you for this question, and we can discuss. We have hot discussions about that. Why we need to use pulse function, and what is the reason? Please make clear your questions that I make a clear answer to your questions if it is possible. So it is very important question. The pulse function must be put as an activation function, or it must be a step function. So what is the question about that? What is the substitution of the pulse function is some of these neural networks that we have defined here. So our question must be in the circle of the neural networks that we have defined. So please try to tell me from the esteemed attendant, please tell me this question. So there is another question here. Based on the data set, how we can decide which technique is good in machine learning? So, okay. As I told you, we have classification and regression, okay? and we have predictive questions, predictive analysis about your data. Okay, so about this kind of data, so we have I have answered to this question the sequel of my presentation, which technique is good for machine learning. So they have been categorized based on all the things that we have covered here. So it's you that you define all of them. For example, about the video processing, at last we reached to conclusion that video processing is good that we use with GANs. But one of the most important questions is why GANs? So GANs, some of the good hidden layer, new features embedded in hidden layers that can process video processing and video categorization too. So you need to consider this question for that. You cannot say which technique is good in machine learning. You need to decide. You need to have this categorization based on the thing: supervised learning, unsupervised learning, and you need, okay, it's good for my application. So how we can decide based on the data? Okay, we have clustering data, we have string data, we have video data, voice data, statistical data. So we have, for all of them, we have introduced many applications in fully in this presentation. So it is very important to pay attention to this PPT. After this webinar, I will put it on ResearchGate and academia.edu, and you can use it. And if you ask me any further questions out of this board, I will answer you, because this question has.
Yes, sir. Yes, sir. Hello, hello. Can you hear me, sir? Professor Hamid, can you hear me?
Okay.
Hello.
Okay.
Hello.
Hello.
Okay,
Hello.
so
I have your.
Okay,
your
I'm really
voice.
enjoying your session. Okay. Yes, sir. First of all, I hope you are doing well in this COVID-19 pandemic situation. I'm really enjoying your session. Lovely presentation.
Thank you
Okay,
so much.
my name is Siddhartha Chatterjee. I am from Kolkata, West Bengal, India. Assistant Professor, Department of Computer Science Engineering. Sir, I have another question. Please tell me the difference between, or mathematical interpretation between, bias and variance in real life scenario. Bias and variance, basically. We know the mathematical non-verbal concern from Google search, but I want to know some real life situation based on bias and variance. Can you differentiate it?
Bayesian analysis.
Yes, sir.
About
your time permits, obviously.
let me tell you about the machine learning in my previous generation with Vihangiar University. I have learned completely about Bayesian analysis and its application by machine learning. So
Okay.
another thing about the cost function, I told you the cost function is about the j theta, and we want to have the minimization, optimization. So optimization is a part of optimization cost function. Optimization is a part of the machine learning. So in machine learning, we have prediction, we have probability, we have a statistical data, a statistical process and modeling, a statistical method, and also about optimization. So all of these processes you need to do, and also embedded algorithms like genetic algorithms, or some of related data are needed to use in hidden layer in order to make progress on your predefined or designed artificial intelligence that is designed by you. So you need to consider these principles together.
If you need more books, more principles, I will tell you by all my means to you to help you. Yes, cost function, I told you about the J theta. Excuse me, I heard it, the pulse function. Excuse me, cost function, yes, about the cost function is about J theta that you need to minimize or optimize, and we have some algorithm to do minimization, optimization data in machine learning and artificial intelligence, and I have talked to them about them in the, but some of the packages that I told you about, MATLAB, Python, Julia. I forgot to tell you about the Julia too. Julia is another programming language by Stanford University that is used for neural networks too. Neural networks like Python, and also Python with Selenium. Selenium is another with Python, and PyTorch as a package of the Python that is used for all usage of your neural networks that you want to make it, for making a telecommunication network like wireless sensor network, WLPANs, low power wireless area networks, everything. You need to consider all of them. So please put an image about all these my two or three presentations of me by on Research Academia that edu, to know more about the relation of these concepts. So at this time, based on this time, I couldn't tell you about this. So if you have more information, please tell me about it. The cost function is about the J theta, as I told you. Yes, J theta, and then you start to minimize based on the embedded algorithms on MATLAB, based on the packages, and you can make the results, and you can find your minimums or your optimal values that you need to consider, and then you put it in the main function. So also I need to tell you, we have a residual function that is called for J theta, and you need to consider the integral for that J theta, for that in order to minimize, and J theta is a functional. Functional means a function into a function. Theta is a function and J is a function. So these are all many sequential definitions that you need to know in mathematics. So that's why I tell you some of your questions that needs to be opened based on the mathematical computations or computational mathematics or numerical
Sir, I have one.
analysis, because on math space. Okay. Yes. Okay, please
Hello.
tell me. Hello, dear Professor Das. Okay, I'm here.
Hello.
Nice son. Okay, I'm here.
Yeah.
I'm here, dear Professor. Okay.
Yes.
Thank you.
Actually, Dr. Hamid, one thing I'm doing, already we are too late. So I
Yes.
am making one thing. I am providing them my mail ID, and there are many active participants here. I have seen many
Yes.
active participants throughout. They have enjoyed your session. Like Siddhartha Chatterjee, he already communicated to you, and he is very known
Thank you.
person to me. Assistant professor in computer science in one of the engineering colleges. So like him, if
Yes.
other candidates are having any kinds of queries or questions, I am collecting
Yes.
those questions. I am collecting those questions in my mail ID.
Yes.
Then I will make
Yes.
it forward to you so that comfortably you can
Okay.
answer to them. And if
Okay,
any
okay,
of
for
the
sure.
okay, and if any of the young minds, like young professors or young students, wants to connect to
Yes.
you through, I mean, if they want to progress in research, connecting in your domain, then also I will
Yes,
request
exactly.
you. if you can help some students of my college so that they can be
Yes.
directly contact with you as a
Yes,
part of your
exactly.
research team too.
It's my pleasure.
Because
It's my pleasure.
yes. Because actually we know each other, but our domain differs. So
Yes,
our
yes,
research domain
yes.
differs. That's problem. But
No, no,
soon we
no,
will
no.
work together.
I think in my idea for all audiences, as I told you, and we don't have any. We are in the same boat because all the specialties that we are talking, we are studying together, all connected together. No, the word is completely different, and I think the main I think has changed its meaning now. We are all in a word that we need to know all these skills in order to improve our for example, our knowledge, our for example, new kind of methodologies and something like that. So I am here by all my means for discussions, for hard discussions, because I really like hard discussions, because every learning process and every new step in your life starts by hard discussions, and I'm not afraid of writing of discussions, because I try to find the answer of the question of the people based on something that they have learned, and if I don't know, I try to do research and find the answers for them. Thank you so much, dear professor.
Yes.
So
So I
science
would
is
like
important.
to and soon we will work. Soon we will work in 5G domain. And now I would like to conclude the session. As I can see, as I can see, many participants are still there. So hope throughout they have enjoyed our session, and they are active too. And I would like to thank, and also on behalf of my college, I would like to say sorry that at the beginning there was some inconveniences, but actually if you see the
it's my pleasure.
yes, but
it's my pleasure.
but actually if you seen the pattern of our webinar, it is not like just to issue the certificate and taking it 30 minutes. We already we already planned with you, so that the participants can gather some knowledge. And very soon I will say, very soon I will share the details of PPT to the participants who really wants it, who really need it, and they will proceed further.
No worries for that. I will share it on Academia and ResearchGate by a citation number, and then they can use it easily. Yes, no worries for that. I will do it. I will do it. Yes, I will do it. Yes. Knowledge is for share, and I will do it, and I am ready to do my best for anything that I can be possible. And if I could do answer of all questions, please accept my apology. And about the cost function, I try to make more explanative description for the Mr. Joy JB that asked me. Okay, I have answered some of the questions and link here in a Word file, and then I will compare and overlap all together to send you about them as a comment, like a paper that we send comments for reviewers. I will be happy to join you, and hope we can have continuous webinars about different types of the topics that I can cover for you, like quantum computing, like, for example, scikit, like Qiskit for quantum computing programming, or many other topics that I have in my mind that I earlier I described for you too.
Yes. Soon I will be in touch with you. I have also planned few topics. Together we can discuss them. Yes.
Very good. And we have and also I have a good news for participants in YouTube. We have new speakers, new invited speakers too, from India that will join us. But it will be as a surprise for audiences. Thank you so much, and I will hope a nice night for you, and thanks for all attendance, and thanks for Professor Dr. Sudipta Das for organizing this webinar. Thank you so much. Thank you so much.
Thank you, Professor Amit. As a coordinator, I want to thank you for this wonderful presentation. Also, we are very sorry for the inconvenience caused in the beginning of the session due to the technical and network
It's my
problems.
pleasure.
But at the last, we hope
It,
that all of you have found this session very informative, and I would like to
Barry,
thank all
yes.
the participants as well as you for your patience and cooperation throughout the webinar session. We are privileged to have in attendance so many distinguished participants and resource persons like you. And I also would like to conclude by again thanking you, Dr. Hamid, Dr. Professor Hamid. Means you have honored us
Like
by
at mine,
presenting this wonderful webinar. We hope to listen from you soon, sir. And I also want to thank you, our active participants in this session. We had a very successful webinar.
I am very thankful to you.
Thank you.
I
And
am very thankful and gratitude.
yes, sir. It's our pleasure. And now I want to request our respected principal, sir, for his closing speech, so that we can end this webinar session. And to participants, I want to say that I will again share the feedback form in the chat box. Please do not leave this session before filling up that form for the successful generation of the e-certificate. And you will receive your e-certificate within 10 working days in your email ID, which we will provide in the feedback form. Thank you all again. Good night. Now, Principal sir, please,
Thank you so much.
over to you. Thank you,
Yes.
Professor Hamid.
Thank you so much, and good night to you. And hope we have continuous collaborations. Thank you so much. It's my pleasure.
Sure.
And have a nice day. Have a nice night. Thank you so much. Okay.
Okay, so
Dear
again,
Professor,
yes. So again, I
Okay.
would like to thank you, Dr. Hamid, and many thanks to the participants or the active participants, because nothing can be successful or possible without the active participants. And there is too many platforms. In future also, we will continue to share with you along with different types of researchers from different domains. And in future, Dr. Hamid, I will try to invite you again on different agenda for my college, so that the
yes, for
participants,
sure, for sure.
yes, so the participants will also get some benefited from out of that concept or the plan I have for them. So very
Yes, for sure, for
thanks.
sure.
Yes, so very thanks to you. So the participants, if you have any questions, please, I have given my mail ID. Drop the questions to the mail ID. I will forward that to Dr. Hamid so that he will get the answers. And again, I am
Yes, for
repeating.
sure.
And again, I am repeating. Apart from this webinar, if you wish to work with Dr. Hamid in his domain, or if you have some research interest, surely you can write a mail to me. I will feel happy to make your contact with him directly, so that the research community get benefited through the contribution by such young researchers. Thank you, everyone, and very good night. Next day, we will see you again on our topic 5G.
If you learn the initial concept little by little, it will be very sweet. Yes, very
Yes.
sweet. We have IoT, we have quantum, Cardinal, many new topics in the world. Industry 4 and Lean have new after COVID-19 and everything.